you seeing?
Now we have a slide before and after.
You can look at my laptop, Michael, because it's on, so it's.
Ah, there it is, okay.
All right.
Try moving it, it may not move. Go ahead.
Okay.
Hey, all right.
All right.
I'm leaving now.
All right. Let's end on a high note. We got a slide to change. We can.
You go ahead, I'm gonna lower some of these lights.
Okay. So 4 of the 5 objects that I improved, I did for a reason. It's because Roger Ivester has a monthly deep sky challenge on his blog. So the first 4 objects that I enhanced are the objects of the month for February, March, April, and May of this year. So I wanted to make sure they were as good as I could make them before I posted them. And the last object is just one that I've meant for a long time to improve. So first, the object for February was the Great Orion Nebula M42. And this picture this is the before picture, which I took in 2018. And I remember that when I processed this image, I had this very sort of innocent feeling that I couldn't possibly have been the person who took this image, because how in the world, when I was a kid, could I ever imagine how far amateur astronomy would come? When you were looking through a 6-inch reflector, you never imagined having anything other than 35mm camera hooked up to it that maybe could take a picture for 45 seconds or a minute before you lost tracking. So to me, to be able to do this was just, it was sort of a religious experience. But then, of course, I wanted to make it better. And this image is, at first glance, you may not notice just what has improved in it, but I'll show you the comparison. So the comparison is this. On the left, the before image, the perimeter of M42 does not have a lot of color in it. You can see it's very pale, whereas the one on the right, the entire perimeter has, the hydrogen alpha glow to it that it should have. A second improvement is that the contrast between the center and the outer regions is more pleasing on the right. And M42 is notoriously difficult to process because the core with the trapezium is so white hot that it tends to blow out the image. And thanks to processing techniques primarily in fixed insight, you can control that, you can arrest it. And I was able to do that even more so in the core of M42 on the right. The next object is the object for last month, which is the Medusa Nebula. And the Medusa is this mythological Greek monstrous woman who has living snakes for hair. So I guess someone who saw this a long time ago somehow imagined that this was the hair of the Medusa in Greek mythology. By the way, you weren't supposed to look at her because you turned to stone. So yeah. So this is before, and it's not a bad image. You can see some of the detail in the nebula. The background's a little milky, but here is my image from this year. And as you can see, you can now also see, in addition to the hydrogen alpha red, you can see the blue of the energized oxygen in the nebula. And although I know the viewers who aren't here can't see the pointer, all of this red area, which is fairly faint, comes out. And the background is much darker. And so the contrast here is a bit sharper. And you can see before and after. Now the third object, this is the object for the month of April. And this is a very small innocuous galaxy in Ursa Major. I'm not quite sure why Roger picked it because it's not a particularly spectacular object. But I started to shoot this back in 2018. And lo and behold, we got this unexpectedly bad period of weather where it was cloudy night after night. And I thought to myself, how could I have such bad luck? Because we never get that in New England, do we?
Never, ever.
You know? So I had to give up on it and I forgot about it. And of course I came back to it when I realized that, well, this is the object that I have to post for this month. And so I finally finished it. And if you look at the two, you can see there's a nicer contrast in the background, and the color is pretty nice in this galaxy, as small as it is. And there's a lot of other little galaxies in the image, and of course, most notably this one here. But there we go with NGC 3039. Now, next month's object is quite a bit larger, and it's M106. And I took this many years ago, 2016. Now, M106 is characterized by a very hot core, which I'll talk to you about in a moment, and then these very thin, faint, but very large arms. So you can see the beginnings of the arms being exposed in this image. And like the prior galaxy, there's plenty of background galaxies to make this a more interesting image from one side to the other. But here's my image from earlier this year. So now you can see the circumference of the arms and much more of the inner detail of the arms, plus the hot core. Now, why is this object so hot and vibrant in the center? It's because it's a Type 2 Seyfert galaxy, which is very active. And there's a supermassive black hole at the center of it. One of the details in this image that I really like, though, are these perpendicular jets of hydrogen alpha right through here. I'm not sure if you can see it clearly, but these are, you know, normally with a galaxy, M31 or M32 or even M90, M51, all of the features are gravitationally aligned in the plane of it. But in this galaxy, these nifty jets are shooting up thanks to the hyperactive core. And so here's the comparison. This is probably the most dramatic improvement of any of the objects that I have tonight. So I'm really glad I went back to finish this one off. Now we get to the object that I wanted to do just for the sake of redoing it.
Phil, I don't want to interrupt, but I think you got part of the erupting core on that galaxy.
I did what, Mario?
You got part of the erupting core.
Yeah. Oh,
There's a streak coming out of the core
right
on the
here?
left side of the core, and
Yeah.
that's real. That's
Oh, yeah.
an eruption from the core.
Cool. Thank you. It was like I was hearing a ghost. All of a sudden, I hear a voice from.
And it's Mario.
Voice from above.
Of all the voices.
Yeah. All right, so the last object was my wide field view of 3 Messier galaxies in Leo, plus a couple of NGC objects. And isn't that a bad photograph? The background's not dark as I would have liked it to be, but you can see the spiral nature of M96 and M95, and M105 on the left is a very large featureless elliptical. These, by the way, I should point out, going back to M106 for a moment. Okay, this galaxy is about 21 million light years away, if I remember correctly. And these are another 10 million further, so they're about 31 million, which accounts for why they're quite a bit smaller. So this is my new image, and this time I oriented it correctly so that north is facing up, and 105 is actually the northernmost of the 3. And the detail on the galaxies is much better, the background is darker, and if I put them side by side, it may not be all that apparent, but then I'll show you a close-up of the 3 galaxies and you'll see what I mean. So the 3 on the left are original, the 3 on the right are after, and they are a lot sharper. And notice the stars too, they're a dead giveaway as to just how sharp the orbital image is, because the stars are a little bloated on the left, but they're very sharp on the right. So I'm happy with the way this turned out. Thank you.
All right.
Ask a question. What does PEO mean?
It means Phil or Baines.
Oh, okay.
That's my
I thought it was a new processing thing.
Yeah.
All right, Mario, you're up. Hang on a minute because I have to let you share your screen. So let's see, make you a co-host. Should have done all this before, but I was busy trying to make it work. All right, you should be all set, Mario. You're on mute. There you go.
How did he?
Mario, you're muted. There you go.
Okay, there we go. Let me put this back up. All right, you should be looking at M81.
No,
No?
you gotta share your screen. Green button
gotta
at the
what?
bottom.
I'm sorry, what?
There's a green share button at the bottom or the top.
Yeah,
Press it.
I thought I did that. Okay, let me try again. Can you see it now?
There we go.
All right.
I must have misclicked. Okay. All right, so you should be looking at M81, correct?
Lovely.
All right, before I start, I just want to say the Dark Sky bill from Massachusetts is in the Committee on Energy, and it's looking good. It's been attached to a supposedly must-pass bill, but we'll see. Things happen. We've got a couple of months. So if I send out an alert asking you guys to send messages to our reps, please do that. We do want to get it passed this year. Speaking of light pollution, I don't know if anyone, I've been so busy. I just came back from Chicago for an AMA meeting, but last fall I was interviewed for an article on NOVA, and they just did the printed form of it. I don't know if it'll go on to become a TV. Anyone see that? I should send a link. All right, tonight I will send a link. You can read it. It's done well. It's about light pollution on Nantucket. Kelly Beatty and myself are quoted extensively in the article. It was well done. It's actually fairly accurate. And I'll be in, for the 22nd of the month, I'll be, now that COVID's recessing down here, I'll be the keynote speaker for Southeast Florida in Fort Worth on Earth Day.
Mario, you're a busy guy. You should retire.
Yeah. And then finally, in early May, in fact, the same day, the next meeting, but I will attend the meeting. There's a European consortium called ROLAND. That means Responsible Outdoor Light at Night. And I'm one of the keynote speakers, but because of time difference, this will be here in the morning and I will be there for the meeting in May. I believe that's David Levy, correct?
That's correct.
Okay, so I expect cake and and pie, okay? All right, so getting on to the talk. So it's spring, spring is galaxy season. And now this is high in the sky. We all see this. This is taken with my 32-inch. And I love this galaxy. It was one of my early favorites as a child. It was one of the images from the 200-inch that I had seen, and it just really inspired me and made me fall in love with astronomy. So to be able to get a picture very similar to what I remember from that picture from a small home telescope just blows my mind, but that's what we can do these days. And this photo has some interesting detail. You got it's a classic spiral, blue arms because that's where the new stars are formed, and the type 2 stars in the center, which tend to be yellowish. And then finally, do you see these little streaks crossing?
Yeah.
When I first took this, I thought that was a processing error. It's not. That is actually cirrus in our galaxy, basically dark, faint, dark gas that's crossing the galaxy. So you can look for that and images of M81. If you get a nice deep image of it, you'll see these cirrus lines crossing it. So, and then just to remind people, all these bright dots, those are not stars, of course. Those are nebulae where new star formation is forming. And what I like about M81 is all those spiral arms are just littered with Orion-like nebulae. Now, I've discussed this in a talk, I think, last year with you guys of why this is galaxy season, which to me is the best time of year. And the reason is, here's our local group. So our galaxy is right here. And when we look in the spring, we're looking to the largest big wall of galaxies. Galaxies tend to form along strings. That's the way the universe is made. That's a whole talk as to why, but there are big voids, and there's voids on both sides here. And when we look in the spring, we're looking at this huge line of galaxies, which is why there are galaxies all the way from M81 north of the Big Dipper, all the way south through the Virgo cluster, and further south through Centaurus and other galaxies. And the reason is because there is that wall of galaxies along the string. We're fortunate that the Milky Way obstructs along here, both east and west, and it doesn't obstruct this huge, beautiful wall of galaxies. So God was fortunate to us in positioning us that way. But that's why this is galaxy season. Now, Phil just showed you NGC 3079, and I was just going to use one of my old images from my 32-inch, which is about twice as big as this. But I took this just to compare to that one, and also because it was the object of the month, and I just randomly chose it. And you can see the galaxy. What I don't add, this was only, I think, 60 minutes, so you don't see that central line that Phil got, which is phenomenal to get that. That's only seen generally in very large scopes. But look it up. It's a active core, and it's shooting off jets in the core. But yeah, although you don't catch that with this, because this really was just a test image for me. The reason I'm showing you this one is because with the 14-inch, I got a wider field. And if you look over here, see those two dots?
Yes.
Okay, Mark Helton from the ATMs alerted me to the fact, and I didn't realize I got it until I looked closely. But that's a twin quasar. QSO 0957. Phil, your image stopped here, which is too bad. If you oriented this way, you would have got it too. But that's a double quasar, and it's 8.7 billion light years away. It's probably lensed, which is why it's bright, and there's probably a galaxy in the middle somewhere to make it lens that way. But,
Mario?
Yeah.
Mario, could you send me a copy of that slide? Because I just did 3079, got a few about 60 images, and my imaging is wide field. So I'll be curious to see if I picked it up.
You should have it. You should have it then. As long as you've got this little star cluster, just look above it. And these two, what look like a double star system is really two quasars, which is, to me, blows my mind. It's 8.7 billion light years away. So look for it in your image. So that's an example of a lens quasar, which to me is far more interesting than just, even though I love galaxy, than just the galaxies here. But even from Florida with a 14-inch, I am getting, there is PGC 28990, NGC 3073. And then if you look in the distance, there's a whole, anything that's fuzzy and not sharp like a star is actually a distant galaxy. And I tried counting, there are about 50 galaxies in this field right here. So I'm happy that I can get that from what I consider a light polluted area here in Florida. So this is about, I think, 25, 30 million light years away. But these tiny dots have got to be around 1 billion light years away. because the ones that are this size, although I know this is part of this, it's just a small galaxy. The ones that are this size that are full galaxy, usually about a 500 million light years away. So these are much smaller, much fainter, and it's just littered with galaxies in the background. So look for that, Barry, when you
Okay.
look at your image.
Mhm.
So, but because of that plume of galaxies, I'm not going to show you all the Virgo cluster. You've seen them, and there are many others. From down here, I can look at stuff you can't see from up there. This is M83. It's probably the furthest south you can see from Gloucester. It is for me. And I got this a couple of years ago. I had to do it over 2 nights because it just barely goes above the horizon, but I had 2 steady nights and I was able to get a fairly nice image with the 32-inch. I really should reprocess it. This is old processing, so I get the core better. But it's a classic, in fact, it's called a Southern pinwheel. And what I like about it is you can see the beautiful spiral arms. And again, all these little dots that are littering along the spiral, I should do this in color someday, is all nebulae. So these are all nebulae creating new stars. And if you try counting them, there are just literally hundreds of these little dots. They look like stars, they're not. Way too far away for that. This one is about 12 million light years away. And it's just a classic example of a small barred SA spiral. In the distance, there are other galaxies as well. Okay. Now, the reason I'm showing you this one, even though I took it from New England, is because we're going to go down south from there. This is known as the M83 group. And just south below our horizon in New England is this beauty, NGC 5128. It is part of it's called part of the M83 group, just like our local group of galaxies. And I find this one of the most fascinating things in the sky. I've been lusting to get an image of this my entire life and cursing every spring when I can't get deep enough in the north. But I'm able to do it easily down here. What you're looking at is a giant elliptical galaxy spearing right through a ordinary spiral. And what's happening is the gas is interacting and it's creating an incredible amount of radio noise as the gas slams into each other. And that's why it's called Centaurus A. Radio noises in nebulae, constellations are labeled A, B, C, D, E, etc. This is one of the largest radio sources in the sky other than our own Milky Way. And that's why it's called Centaurus A. And I just love the detail of the giant elliptical destroying and merging with a spiral. Now, this next image is not mine, but I want you to see what's happening. So here, this is at a 90 degrees opposite, but here is that spiral. This is through a professional large scope. And perpendicular to that, you can see these giant lobes. That's not visual. This is radio imaging, which you can't see visually, obviously. And all this is radio imaging superimposed on the visual image. So you can see what's happening. There's a very active core, another reason why it's a radio source. And these jets are coming out because of an active core from both sides of the black hole in the center. It's a beautiful object. It's fantastic visually as well. So also deep down south in Fornax is 1097. It's a nice spiral with, again, lots. I know I got a good picture when I can see the nebulae within these spiral arms. Like here's a beautiful string of nebulae. Again, not stars, nebulae, all along the spiral arm. This would make a nice, I'm kind of just experimenting right now at the C14. Next year, I'll try getting color pictures of all these. And again, there are different deep sky galaxies. This is another one, 1365. It's also in Fornax. It's a beautiful barred spiral, and you can see nebulae in the spiral arm. And a little bit of disruption up here, I think, because there's a faint galaxy supposedly over there interacting. Now, this is not a galaxy, but it might be a captured galactic core. We all know M13, we see that every summer. This is NGC 5139, also known as the Omega Cluster. And it's a huge, it's the largest globular cluster in the sky. Visually blows you away. But I was able to get some nice detail with the C14. It's actually bigger than the field of view. So it would be way too big for my 32-inch. Actually, my 32-inch field of view would just be the core. But it has about 5 million stars, whereas M13 has about 500,000 to 750,000 stars. And it's so much bigger that people think that it's actually a captured core of a satellite galaxy that got stripped of its spiral arms and gas by the Milky Way, and now it's just the core of the galaxy, which looks like a giant globular cluster. Now, also deep down south, this is in the Centaur as well, is NGC, I'm sorry, this is in Vela, is NGC 2736. This is part of the Vela, apparently an outer arm of the Vela supernova remnant, and kind of reminds you of the Veil, but it's basically gas from a supernova slamming into dark gas up here. And here's another section. So I'm able to get Vela, which I just labeled Vela 1. I was experimenting. There are other stuff around it. These are all stuff from the Vela supernova remnant. So what I'm going to do next clear night is try to capture this with my wide field scope and see if I can capture large parts of the veil. I may even do a mosaic to really give it to capture it all. It's as wide as 2 full moons, so it's a big object and way too big even for the C14, except getting close-ups of selected parts of it. And this was a supernova that apparently erupted 30,000 years ago. And deep down south, there are other objects that may prove interesting as well, like GUM 15. It's a nebula forming region. My first GUM object, those are all in the southern sky. Then you got SH 301. This you can get from New England, but it's deep down south. It's in Pappus. And then this is the SH2 302. And that's another nice star forming region. So that's what I've got. Happy to answer questions if there are any.
Okay,
Thank you, Mario.
thank you, Mario. We do have some questions, right?
I had some questions.
Go ahead.
Can you hear me? I put them in the chat, but are those twin quasars? You may have said so, but I was trying to write this down so I could look them up later. Are the twin quasars bound to each other, like gravitationally, or is it just a visual?
It's twinned only in the sky. It's actually a single quasar that got gravitationally lensed and doubled.
Oh, yes. Okay, you did say that then. All right, so that eliminates my other 2 questions. Thanks. Nice set.
I get. I'm happy I can get astro images down here with such primitive conditions with a small scope.
Any other questions for Mario? All right, well, thank you, Mario. That was wonderful. Jeremy, you're up.
Wait, one last question for Mario. What was the last 2 images, SH2108 and the one before that?
The SH2 302.
302.
One before that was Vela, just part of the Vela Nebula.
Thank you. And Phil, good presentation. You also.
You get it? Yep. Okay. Well, it's gonna go out to everybody of doing that, so, sure.
Or if you want to do that before you share your screen.
I can skip the video altogether, whatever is easiest for you.
I'll tell you what, do the photographs and then we'll do the video. Does it work in that order?
Yeah.
Okay. All right, folks, Jeremy is up next. He's got a video to show, which is we're gonna have to play with the equipment a little. That's always a good time. He's gonna give you some photographs first, and then we're going to get one of his wonderful musical videos. While he's setting that up, can everybody hear me all right?
Yeah.
All right, I wanted to announce that thanks to Mario, our guest speaker for next month is globally famous comet hunter David Levy.
Whoa.
Oh, good. Oh, wow.
Yeah. So thanks, Mario.
Wow, that's incredible.
Yeah, so we're very pleased about that.
He's a good friend of mine. He couldn't say no. I know where he lives.
Well, we're really looking forward to that, and that'll be right here again, not just like this.
Whoa, whoa, whoa. Great.
No, he's gonna be somewhere in the desert. Okay,
All right.
so
Thanks,
it's all
Michael.
yours.
Well, thanks a lot for having me. To echo what Phil and Mario said about amateur astronomy, I honestly didn't know that amateurs could get images like this. So and it wasn't really until probably 2017 that I kind of discovered this, because I stumbled across this guy named Trevor Jones who has a YouTube channel called Astro Backyard, and that's how I kind of discovered this whole hobby of amateur astrophotography. And that's when I got my first telescope. I started off doing visual. Then I took my DSLR and put it on the back of the telescope, and I got Orion for the first time, and I was like, couldn't believe it. So I'm gonna take my mask off because my glasses are fogging up. So that's kind of what got me started. So I started off with a DSLR, but then a couple of years ago, I kind of upgraded to a dedicated astrophotography camera. And without getting technical, basically, it lets you see just the gases, just the frequencies of light that come from the certain gases that are being, like in this case, it's an emission nebula, where certain gases are only going to show a certain wavelength of light. And so by having the right equipment and only seeing that light, you get to filter out a lot of the light pollution that everyone is battling. So that was a huge step for me. So what you see here is the Heart Nebula. Let me get my notes, and then I'll zoom in so you can see some more of the details. But this is 7,500 light years away from Earth. It's in the Perseus arm of the galaxy in the constellation Cassiopeia, and it's a large object. I mean, it's many full moons across, and because my scope is a wide field scope, it's perfect for this kind of object. And this image I took is from home, about 12 hours worth of exposures, and I'll zoom in here so you can see more of the detail. There's this, in the middle of this sort of structure you see is known as Malot 15. It contains a few bright stars, nearly 50 times the mass of our sun, and many more that are only a fraction of our sun's mass. So this is basically the result of gas being ionized by the radiation from the stars nearby. So the gas is basically glowing, and that's what you're seeing. And yeah, there's just a lot of great detail that I was able to capture. And this is from home, where I live in Chelmsford, so the light pollution it's pretty bad because we're so close to Lowell. But nevertheless, with the setup and a decent amount of exposure time, this is a great target, and I'm hoping to get some more time on it. And by the way, this is all sort of a false color image, which means the gases, it doesn't look exactly like this. If you could see it with your naked eye, I kind of approximate it, but something I want to mention too. And I got one more image that's, oops, hold on. These are all in my videos. I know, kind of a spoiler, sorry, but this is the other one that isn't in my video. This is the Rosette Nebula. This is one of my favorite objects. It's a really bright emission nebula. It's located in the Monoceros region in the Milky Way. The open cluster NGC 2244 is closely associated with the nebulosity, and the stars of the cluster having been formed from the nebulous matter. So this is about 5,000 light years from Earth, and it's measures roughly 130 light years in diameter. And once again, there's a lot of great detail as you zoom in and around.
How many hours of exposure do you have on this one, Jeremy?
This one is 7 hours from Chelmsford.
With what aperture telescope?
It's a 4-inch refractor.
That's the nuts.
So yeah, these are basically my two newest images. This one was taken back in January, or at least mostly, and then the one before that was taken back in November, and we haven't had many clear nights aside from those two that I was out. So yeah, that's partially the reason why I don't have so many new images, but the other ones that I'm flipping through here are in the video. So I don't know, Michael, if you're able to find it.
Okay, folks, sit tight. I have to open my email and get a video.
I'll stay sharing until you tell me if you want, or never mind.
Yeah.
Nice job.
Thanks.
Questions? Can we take a question?
Yeah, go ahead.
This might be a really dumb question, especially for somebody who's done a lot of visual, but if we were this for the Rosette, how much of those gases would actually be visible to us, to the naked eye?
They're mostly I think they're all in the visible light spectrum. I mean, some of HA is still visible, hydrogen alpha, but it's on the redder side. So if your eyes were sensitive enough and you had a big enough telescope, you could see it.
Well, I guess my point is we look at pictures of our galaxy and it's all really bright, but when we look up at the Milky Way, it's very, very faint. And I wonder about nebula gases and wonder why I never asked that question when I was there viewing with you guys. Like if we were as close, how visible would those things really be? So
Well, it's the apparent magnitude of 9. So through a decent telescope, you'd be able to, a large telescope, you'd be able to see sort of the faint.
It would be milky white.
Yes, it wouldn't really appear to have a lot of color. Like if you ever looked at the Orion Nebula through a scope, it doesn't look all that colorful. It's more grayish, sort of. I mean, unless you've got a really gigantic telescope, yes.
So, but the upshot is that all of this, without the telescope and the hours and hours of collecting photons, all of this would be very, very faint, even if we were just floating in space this far away looking at it, right?
Yeah, yep. And our eyes are so much less efficient than modern cameras. It's, few percent efficient. So a few percent of the photons that come in your eyes actually, or come, few of the photons compared to almost all the photons, like today's monochromatic CMOS cameras will tend to gather. So.
Right on. Thank you.
All right, so I should be able to.
There we go.
Are you getting sound?
Yes.
Yeah.
Yeah.
Want me to turn that up?
Yeah. Concert level.
Oh, it won't turn it up for you, but it will for us. Ha ha ha.
We almost there?
Almost there.
Where are we?
That's the Pemmy Overlook in Lincoln, New Hampshire.
Grandma's house.
Yeah. The monolith. Ooh, ah.
Yeah, it's my headlamp.
No, I'm gonna regret this.
All right.
Look at that view.
Oh,
Oh, I can make you louder here, Michael.
Pardon? Sorry.
no, I don't see it.
Wow. No, I drive.
Nice.
10 years ago was M42. So I said, well, let's just start off with M42 because like Phil had mentioned, it was the image of the month for object of the month for Roger Ivester, and we'll start off with that. So anyway, this is what I did 10 years ago. Simple, everybody remembers me. John was the one who helped find my, or at least guide me into getting my first telescope. And lo and behold, I had a 90-second image and a 60-second images stacked up to make it nine minutes of exposure. So that's what, like Jeremy had said, I was amazed that I could do this because 10 years prior, or 20 years prior, I wanted to do it with film. I said, So this is what I'm using now, and just so everybody gets calibrated. Similar to what Jeremy said, I live in Marblehead, so I've got a fair amount of light pollution. Mario, you now can empathize with what I have to go through all the time, and I do everything in a far field f/2 RASA telescope. So my it's similar to like a SCT only and Hyperstar, only it's already built in to the Celestron scope. So I'm doing very fast imaging, and therefore I can get a lot of images. And I've got a very, very sensitive CMOS ZW optics camera. It's a one-shot color. So here's what I submitted for M42. And you'll see that I processed it, similar to what Phil had said, I've processed a lot of images. So I've got 175. And with M42, we know that it's a grouping of 2,000 stars located in the sword of Orion, which is below the belt. It's 1,400 light years away. It's got 24 light years across, and it's the closest region in our galaxy with massive star formation, closest to Earth. And the trapezium, which is, can you see my mouse?
Yes.
Okay, so the trapezium is the center core area. And one of the challenges I had here, you'll see that I have 5-second images and 20-second images. And I had to blend in the 5-second images with some guidance from Phil using both PixInsight as well as Photoshop to bring out the core. What I did read up is that there were actually 6 stars within the core. If I were to pull out the 5-second, you can just barely see 4 of the 6. And apparently the 2 of those 4 are double stars or binary systems. But what I'm pleased about with this image was the detail that I was able to bring out, which I'd never been able to do before. And this was done over 2 different sessions over 2 years apart. So the next image is going to be, next pair of images are two nebulas that I find them to be so similar with the way they're presented. It's the Trifid Nebula and the Cocoon Nebula. They both have an emission as well as a reflective nebula, but also you've got these open star clusters within it, as well as these dark nebulas. The similarities is that.
Jerry,
Can you hear me?
keep your head straight or the sound goes
Okay.
away.
Okay, I was reading from my, I'll move my sheet over here. So the Trifid is 4,100 light years away, whereas the Cocoon is 2,500 light years away. The Trifid is 21 light years across, Cocoon is 15 light years across. So you could see so many similarities. In both cases, you could also see that I've got 189 images as well as 222 in the Cocoon. 127 minutes, 95 minutes. With f over 2, you can multiply by that 10, and you'd get an f over 7 equivalent of exposure time. The other thing is that in both cases, you have a lot of star formation region. When I did a little read up on it, in the Trifid, there's a stellar jet that protrudes from the head of the cloud and is about 0.75 light years long. The jet source is a young stellar object deep within the cloud. So this is, I really like the colors, the dark nebula, the dark lanes that are within this. Mario brought up this one, Bode's Galaxy, and I really, it's one of those that I keep improving upon. I did this a couple weeks, about 6 weeks ago. And what was amazing is that my one-shot color camera has a very strong sensitivity to red in the IR region. So the star formation regions that Mario was talking to, I actually was able to pick these out. You see the little red dots there? And so these are those star forming regions within Bode's Galaxy. The next one is the Whirlpool, another one of my favorite galaxies. With the far field, I'm able to pick up other galaxies in the field. Obviously, with the Whirlpool, you've got the M51, and it's got its dwarf galaxy NGC 5195. The overall width of the size of the object is actually half the size of a full moon. But I also was able to pick up 2 additional galaxies, one here and one here, NGC 5198, IC 4263. And when I looked it up, they're actually 129 and 123 million light years away. I'm pleased about that because I don't think I've ever gone that deep as far as being able to identify those galaxies that far away. The next one is, I redid this one. I've done it a couple years ago, but once again, I had 120 images of the Whale Galaxy and the hockey stick. And with the Whale Galaxy is a spiral galaxy on the edge, shaped like a whale. You could see the detail I'm able to bring out with 122 images. I wasn't able to do this a few years ago. There is a dwarf elliptical NGC 4627 right nearby. And then the hockey stick is the 4656. The bend is due to the gravitational interaction with the Whale Galaxy. So these two are interacting together. And then the last image that I have is, as Mario said, this is a galaxy season. I took this 2 years ago, and I took a deeper dive into the processing and reprocessed it. But this was over a 2-night session, 138 images, 25 seconds per image, and for a total of 58 minutes. And you could see it's Macarian's chain, or part of it. The chain has 8 members, 4 of which I have identified here. The ones that I do not have really keep going to the upper left. and they are out of the field of view as NGC 4473, 4477, 4461, and 4458. I have a wider field of this, which I presented previously, but I did read up, and it says that 7 of the 8 members are moving coherently, so they're moving together. The M84 you've got here, it has 2 jets of matter shooting out from the center. It's an elliptical lenticular galaxy, which is 60 million light years away. There are also 2 sets of galaxy pairs. This is one of those sets, which is, let's see, 4435 and 4438. So what I'm going to do is I'm going to identify them all. So the ones in yellow are the major galaxies within the group, but I took a deeper dive into it. I can go back and forth. I actually found these little faint galaxies. I have no idea what their distance is, but what I've been able to show is that I've got 13 additional faint galaxies here. You've got the 4402, which is down, where was that? What do I have? 4402, that's an edge-on spiral. 4387 is right there. That's an elliptical. 4388, that's a barred spiral. I'm sorry, that's a spiral. 4313 is a, I'm sorry, 4388 is a spiral. 4413 is a barred spiral. 4425 is considered a barred lenticular, and that's why I said that 4435 and 4438, okay, up there, there's an interaction going on there, and also they're called the Eyes Galaxy. So anyway, I did identify, I found some star charts, and I did identify these. Does anybody know what the VC stands for?
No.
Apparently not.
Okay, I know I looked up PGC, and it's called the Principal Galaxy Catalog, which they started forming in 1989. But I was just pleased that I was able to pick up all these faint little galaxies. There's one here, there, on this one. It's not me. Oh,
Somebody burned the pie at the clubhouse.
Hey folks, we have a fire alarm here. I don't know how long it's gonna last. Stick around if you wanna stick around. We'll see what happens. Otherwise, we'll try again next time. Don't forget David's levy next month.
yeah, Michael, I hit my last slide, so.
Okay. It's a little noisy here.
I guess. Another advantage of Zoom, I can mute.
All right, folks, good night. This is insane. Hey, Jim, good to see you.
Thank you, Michael.
Thanks, Michael.
Frank, good to see you too. Dwight, thanks for coming. Alvin, hey.
John, I'm sorry you didn't get to do your show tonight.
Better luck
Good night,
next time.
everybody.